Welcome to a new session. In this session we will discuss an implementation of a simple UML, just two levels of inheritance, superclass and subclass. But we have some special cases and we need to discuss them. So first of all, let's go through the question. Consider the given UML diagram and you know what this represents. This is not new to you. However, we will just try to implement it together and see how things go. Implement these two classes and define the provided methods by printing out the sounds of birds. So we have birds as a class, okay, and we need to define set sound. The sound of birds, you can just say tweet, okay, birds tweet in general, and crows in particular. So we have also the name of crows. We need to declare it, or you can say define it, set the sound. We will speak about that later on, I mean within NetBeans. So in the crow class, create a main method that instantiates these two classes. Then call the setSound method using the instances you have created. So we need to instantiate birds class. We create an object of it. And also we need to create an object of crow, and we need to see how things go from these two instantiations, because we need to call the set sound from both of these and see how things go. We can create these two set sounds as constructors, so we don't have to call. Actually, they will be called automatically. We can do that. That's possible. So let's just go ahead and do it. Okay, let's go to NetBeans. Okay, let's create a class from, we call it birds. Okay, we need to have a set special definition here. Okay, initially I will not create it as a constructor. I'll just use a method, normal method. So I will use public as an access specifier. Void, we don't have anything to return. Set sound. The sound of birds is tweet actually. So we can write a statement here, birds tweet. Okay. Right. Then we need to create a subclass of this, Java. And we call it crow, or crows in plural. And we do the same here. Public also. Void, we don't have to return anything. We don't have any return. Set sound also for the crows, and here we don't have any argument to be received, and we say just a declarative statement, crows caw. This is the sound of crow. It's called in English caw. So basically we have two methods with the same name. This is the first observation. In the subclass, in the superclass and subclass, I haven't extended, so I must extend first. Extends birds. Okay, here's the thing, here's the idea. Now you can see that we have this green highlight, and if we see it, overrides method. What's overrides? So this is the first question. What do you observe? Actually, we have these. I'm very sorry. I mistakenly opened the recorder. We have these two classes, the superclass, which has only one method, setSound, and the subclass, which has also one method with the same name as the method in the superclass, also with the same signature. We don't have any difference here. Same access specifier, same signature. Right, in inheritance, or in the concept of inheritance, this is what we call method overriding. If you remember, we studied something we call method overloading. We have the method's name, same name. However, we don't have the same signature. We don't have the same argument list. So this is what we have as method overloading. And you studied it before, and we discussed it in many, examples. So now we have method overriding. We have a superclass and subclass, and the outcome of these classes will be declared once we create a main method driver class to instantiate these two. So what's requested from us is to instantiate these two. Let's create a driver class. So here we can say overriding demo. We should say method overriding. Just for simplicity, I'm writing it this way. Okay, and this is a driver class that must have a main method so that it executes properly. All right, so let's create the main method, public static void main. And here in the main method, we need to instantiate both classes. Change access specifier later on this one. We need to create instances of these two classes, the superclass and the subclass. So now let's instantiate both of them. Birds. Let's say object1 equals new birds. We don't have any constructor. However, let's just call the method that displays what birds do as a sound, what kind of sound they produce. So object1 dot set sound. Okay, let's go to the crows object2 equals new crows. We don't have any constructor, so this one will be left out. And we need to use object2 to call the method here, set sound. So this is what's requested at the beginning. Let's just run. Birds tweet, crows call. I should say crows here. I'm very sorry, it's just typo. Okay, crows call. Okay, this is very good. What we expect, because we instantiated two different classes, although crows inherit the methods and the attributes of birds, which is a subclass of birds. So now the idea next to this is, okay, we need to change the access specifier. Before that, let me just do this. Well, let me use this instance to call crow. Okay, new crows, and here object what set sound. So what I did, I used the base class birds to instantiate an object from crows, which is the subclass. So what do you expect the sound will be? Is it the bird sound, tweets, or the crow sound, call? Let's just check, and then I'm here. Let's just check crows call. Well, we use the superclass to instantiate. Why didn't we get birds tweet? Simply because the method here overrides the method in the superclass. So this method set sound has the same name and the same signature of the method in the superclass, so it will override it. And this is what we call method overriding. We can override a superclass method in a subclass. And one more thing. Now I could create an instance of a class using the superclass birds. While this birds actually as a class is not the same class as crows. So what is the idea here? This is what we refer to by polymorphism. So we can create different instances from the superclass or the base class for all subclasses. We may have a hierarchy of subclasses. So all these subclasses can be instantiated using the name of this superclass. So we can instantiate all of them. However, we cannot work it in reverse. We cannot use crow to instantiate birds. That's not possible, to give you a syntax error. All right. What kind of tolerance do we have in method overriding? What does it mean by this statement? Well, we have an access specifier here, public. If we change it, what will happen? This is the second part of the question. Change the access specifier set sound method in the superclass to private, and then try to call it using crow's instance. What do you observe? So let's change it to private, and let's do this here. Oh, seems that we have a problem. Well, let's try to run. Definitely we have an exception in this case. Why? Because we are trying to override a private method, and that's not permitted. So what kind of methods that we can override? We can override public methods, as you just saw earlier, or actually methods that have the package, you can say definition. That's possible. Also, we can use protected methods, and this will work for us. Let me run. So it just works fine. Let me remind you that you should distinguish between protected and public, and I will leave the idea of distinguishing to you to revise it. Private is actually restricted to the same class, or the methods that are actually within the same class, or all sub classes from the same class. We can access to the private members as long as they have the same, or they share the same superclass. However, for public has its own access. If we are in the same package or the same source package, we can access to it, all of it. If we are in another package, we can also access to it. How about protected? Double check if we have an access from outside of the package or not, or just within the package. Double check it. This is actually an idea for you. Usually we ask such questions on the exam about distinguishing between protected, private, and public. And I think this is the end of this question, yes. So that's good enough for this session. We'll see you in other sessions. Have a good time. Goodbye.